Sometimes I think the word game is stuck on almost everything that isn't serious. If you play music, if you draw pictures with a computer, that's not a game. You don't get a score, but we call it games, and there's sometimes this down thing. Don't play games, don't play around on the computer. And yet there's a lot of good can come from game playing.
What's up, everybody? We got another stream. We're just doing streams every day, apparently. I wasn't planning on this. Forgot to turn my fill light on. There we go. I am going to turn off the live stuff, mainly on, let's see, on this view here, because what I'm going to do, I'm actually recording this to my PC. I'm going to cut the segment out when we do the power adapter assembly and make this into a separate video. So killing two birds with one stone, so to speak. So, if you guys saw the video last night that I posted about the Ender 6, that weird grinding noise I was getting or the noise I was getting from the extruder ended up being the motor itself. It's just too damn big. I ended up putting a pancake stepper on there, and everything's working perfectly now. So, the printer's printing. I cranked these out at 100 millimeters a second on the Ender 6, so print its own parts. Not terrible. And these are the blocks I designed. So these will mount the EZNeo strip to the top rail of the Ender 6 here, and also clear the magnetic portion. The strip itself will bolt up to the block through its little mounting hole here. And then you'll put one of these screws through here with a T-nut on the bottom, and this will bolt to the extrusion. So this will give it a little 20-degree angle, so even when the bed's lowered down, it's going to cast the light into the printer bed. I didn't want to have it just straight on, because then once the print gets lower, you're really not going to get much lighting. So I figure a little 20-degree angle would be good. So what we're going to do is we're going to first assemble the universal power adapter. Now, the only time you need the universal power adapter is if you have a board that doesn't have its own onboard regulator that's capable of supplying 1 amp of power. Now, 1 amp is absolutely worst case scenario. The typical draw we've measured on these is between half an amp and 0.6 amps, but I like to be safe in rating our stuff. Now, the stock board on this printer does have a 5-volt regulator, but I don't know what Creality's official rating is, and I'd rather run a separate power adapter to be on the safe side. We all know that these boards typically aren't designed very well, and I don't want to add a light load to it. So what we're going to do is assemble this little step down we have here. This is preset to 5 volts. You can feed it anywhere from 12 to 24, and it'll put out 5. So it's pretty simple. There's only 2 wires that have to get soldered for that board. We already have directions on how to assemble this on our website that are step-by-step with pictures, but I'm going to show you today in a video how to do it. Also, just as a thank you for you guys watching, and we're not going to post this anywhere but talking about it right now, I made a 20% off code for the EZNeo. So if you want to pick up our EZNeo lighting kit, that will take 20%, which is $5 off of the strip kit. The strip kit it comes in this nice little package here. Griffin over at Paquette Engineering is the one who designed these for us. You've got the actual signal and power cable that comes with it. This little baggie normally has these screws in it, so there's 4 M3x6 screws, 4 M3 T-nuts, and we're going to use the hardware that comes with this to mount it to the printer. So there's no additional hardware required to mount this on this printer that we're doing. And these are actually really nice. I really like these. These are to clip into the extrusion to hide the cable, and we're going to use these when we route the cable down the extrusion into the bottom of the printer. So, yeah, so the code is EZNeo 20% off. I'm posting that in chat right now. So if you guys want to order an EZNeo set for yourself, for your printer, you can use that and save some money. So, and they're in stock and ready to ship. We have them ready to go. So anyways, let's get to it. I'm going to switch over. I will be talking a little differently because, like I said, I'm going to cut, when I'm doing this anyways, I'm going to cut this portion out and make it a separate video. I'm recording to my local PC, so then we can make that a separate video. So let's get to it. So the first thing you're gonna need. All right, hang on. I got to put on my professional hat because this is going to be a product video. Hang on. All right, hang on. Let's make sure this is all in frame really nice. Got to make sure it's all perfect, okay? All right. I think I'll zoom in a little bit. How's that? Yeah, I think right here would be good. Make sure I keep everything in frame here. We'll see how this works. I don't think I've done this before with a product. All right, so make sure my soldering iron's on. I'm going to show it. Soldering iron. And some solder. Where's my solder? Oh, it's on the reel. All right. Go ahead and grab some solder. Oh, wait, I already have some cutoff here. All right. Okay. Okay, let's put on the professional hat. Oh, wait, hang on. There we go. And I'll have to record an intro and outro later. But anyways. So, here in front of me, I have our universal power kit. Now, inside this package, you will get a couple of little male to female DuPont jumpers and the module itself. Now, this module, you have to pay attention to which end is which. You have the end with the larger red plug on it. This is your input side. And the output side is the one with the little white plug. So the first thing we're going to do, and I try to keep the same colors as the cut. So I typically will keep the same colors for the power input, just so I don't get confused when I'm wiring this to my power supply, because we're going to insert these into the ends here. So I'm going to peel off my red and the black here from the bundle of wires. And this is a really simple step. You just put the black into the black side of the plug and the red into the red. Now, these two ends here will go to your power supply. You can put 12 to 24 volts in here. Now, if you want a cleaner installation and you don't mind doing some extra soldering, you can go ahead and just solder some extra wire onto here, and you don't even have to use these. Now, this is where we will have to do soldering. This is the output end. So I'm going to take this and snip the little white end off of the output side. And we're going to want to select two wires to use for our output side. I'm going to use brown for my ground, and I'm going to use the orange for my positive. It doesn't matter what color you use. This is just what I'm selecting. Now, how long you want to leave these is up to you. I'm going to cut these right about here. And we're just going to solder these onto the wires that came on the output side. Now that I'm thinking about it, this is not going to be in the actual video, but now that I think about it, if you're going to wire these, if you're going to do this method, you could just cut this here and use bare wires to go to your power supply. What do you guys think? What do you guys think? Should I have the video show that instead? Because normally what I do, or what I did in the text document with the images, is we have two separate cables and we cut them. But we can just strip these and put these into the power supply. What do you guys think? Looking for your input here. Do 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 do. The only reason I say it is so the colors match. Chat. Why is chat dead? I mean, I know there's a YouTube delay, but shit. I mean, it really does not matter what color you use as long as you remember which goes to which. Cut and strip? Okay, we're going to do that. So we're going to pretend like this never happened. And then I'm going to show this. All right, so basically I'll cut from where I cut this off and insert that. So, you know what? Yeah. So now we have the red and black into the red end here, and I'm going to cut this off. So I have the male ends here of the DuPonts, and we're going to use these on the output side. So the next thing we need to do is strip these wires here and these wires, and then we're going to solder them together. I'm going to use heat shrink to terminate these. Nope, not terminate. That's the wrong word. Now you guys get to see how many cuts I have in a product video. Live. So now that I have my red and black male ends, I'm going to cut and strip the ends of the output side of the step-down module and the ends of the male end. Ah, that sounds weird. Hang on, let me try this again. So now I have the male ends here that are red and black. I'm going to strip both sides of these wires, solder them up, and I'm going to use heat shrink. You can use electrical tape if you don't have heat shrink, but since I have heat shrink, I'm going to use that. Where's my heat shrink? Here's my heat shrink. It's over here still. That's from the last video. Guess I need to have my hot air station on. I think this heat shrink will suffice, will it? Yes, it will. It'll slip over there. Maybe I'll go up a size. I feel like that's too tight. Okay. Well, I guess it doesn't matter. I mean, I'm going to cut this out anyways. Silicone wires. Yeah, so this is really the only soldering you guys have to do with this. If you have a printer that needs a supplementary 5-volt power, this is basically the hardest part of the whole installation. So we're going to go ahead and twist these wires together, and then we're going to solder them. We're going to do this for the red and the black wire. That's a nice twist. Nobody likes a dirty tip. And now we're going to repeat for the red wire. And all I have left to do now is pull the heat shrink over and shrink it up. I'm going to let my hot air station... Uh-oh. Are you guys still, can you guys still hear me? OBS is, like, locked up. And we should be back. I need to check my recording, although I guess it's streamed. I could pull it from the stream, but I prefer to operate from source. Let's see. Damn you, OBS. Come on. Yeah, we should be back. Let me see if I... Sort by date. Did it actually successfully record that? Let's see. 510. I'm going to let my hot air station... Uh-oh. Yeah, so it did actually record. I don't know why it locked up. Anyways. Okay. All right. Back to the professional video. So now that we have the male ends on the output side, We're actually doing this because we're going to take these ends and insert them into the JST plug that is on the EZNeo strip. So we're going to put the black wire into the black wire spot here on the plug. And you see here I'm matching up the black to the black and the red to the red. And we'll have to put one in the center here. So I'm going to grab my assortment of DuPont jumpers that came with the kit. And I'm going to grab the white one and put that into the end of the plug here. So when you're done, it should look like this. And then to give this module itself power, you will strip these two wires and put them to your power supply's output. One other thing I like to do is I will either wrap the end of this with some heat shrink or electrical tape just to keep these from pulling out. They do hold in pretty well, but you can do that before you install this into the printer. It also just gives it a cleaner look. So I'm going to go ahead and put some heat shrink on this, and then I'm all done and ready to put this in my printer. All right, I think that'll be it for the video. Don't need to get more complicated than that. About how long that can go half. Yeah, so I like these little modules because I'm going to cut this out, obviously. The reason I like these little modules is because they're so small and they're preset to 5 volt. Now, you can obviously get other step-downs, and I think we're only charging $5 for it, so it's not like we're gouging you $20 on them. So, anyways, I'm going to go ahead and heat shrink this, and then we'll move on to installing this in our Ender 6. And I'll stop the recording because I think OBS doesn't like recording and streaming at the same time for some reason. So do one side. I guess I will add one other thing. I'll cut it up. Better to have more content than I need than too little. So back in professional hat mode. I'm just waiting for the hot air station to shut off. Come on, you can do it. There it is. So now I have the heat shrink on the JST and the DuPonts, so these will not come out. All I'll have to do to install this in the printer is strip these and connect these to my power supply's output terminals. And then this white wire here will go to whatever I/O pin you select to use on your board. All right, there we go. Got some footage to edit later. Knock something off my to-do list. I wanted to do a video on installing that. Okay, so yeah, all I literally have to do now that this is made, is, like I said, hook these wires up to my power supply. This will go to an I/O pin on our control board, and this other end will go in the strip. And then I tell the firmware what I/O pin I used, and the lights work. There's not that much to it. So let's switch over to my Ender 6. Or actually, I'm gonna show you guys how to assemble the little blocks I have here. So it's definitely gonna be easier. Now I want this plug on the right side of my printer, so it's gonna be mounted in the printer like this, and these are gonna go up towards the top of the extrusion. So I want to put the blocks in this position. So, all right. And I'm going to put them on the 2 outer screw holes. So if you see here, we actually have 3 sets of screws. And we're not going to use the center one. You can get cheap rolls of NeoPixel strips, but as far as I know, we're one of the few companies that actually has a PCB design instead of a flat flexi strip. For printer applications, I really like these because they just last longer. And the benefit is this PCB itself acts as a heat sink for the lights, and heat kills LEDs. So, all right, I'm going to take 2 of the screws that were included in the kit for the mounting of the strip to the block, and then we're going to have 2 more screws and 2 T-nuts that will go through the bottom, and then we'll screw this to the printer. So where's my... I'm going to use the Allen key. So we do include an Allen key with the EZNeo kits for the screws. It's just a 2mm hex. So I'm going to go ahead and put that through there and thread this into the printed block. Now I did taper the entrance hole of the block, so the screws actually just kind of walk themselves right in there. I should have used my screwdriver, but these are nice to include with products in case somebody doesn't have one, but I much prefer using a screwdriver. So, and I have these holes sized pretty well, so they don't be loose. Look at me designing stuff. Only took me like 3 years of having a printer to actually learn Fusion. All right, so I'm going to drop the M3x6s into the holes here, and then put a T-nut on the bottom of each one. So there we go. See, it's poking through, and just get on there a couple threads. And these files are already on our website for the STLs here. They're located in the Help Center. I did not put them in the store as a free purchase yet. I might. But they're on the site. All right, so you can see here, I got my T-nuts in. I've got the strip mounted to the block, so I'm going to put this on my Ender 6, and then we're going to run the wires. All right, so let's switch over here. We don't want to see my ugly face. All right, and where we're going to put this is I'm going to center this right here. So we're going to mount it right here. Hopefully I oriented everything. So we've got I want my cable to go here and then down this extrusion. So I'm going to go ahead and put this in. I want to put that in the top extrusion. And I'm just going to eyeball this and have equal spacing between the edge of here and there. All right, that one's in. Come on, T-nut, twist. Twist. Oh, yeah. And look at that. Clears the door, too. The first version I made did not clear the door, so this is like version 3. Yeah. All right, so I'm going to show you what I'm going to do in terms of routing the cable on the Ender 6. I'm going to unplug my power before I do this, because we're going to go into the bottom. I still have the bottom of the printer off from the last stream. Why is my camera all wonky? All right. Oakley dokley. Now, I should be able to feed this down into the bottom corner here, I'm assuming. Or is there stuff in the way? I wanted to feed this down into the bottom here. Ooh, there might be stuff in the way. All right. That's okay. We can work around it. All right. So I'm going to plug that end into the end of the pixel strip. I'm going to grab those cord covers that come with it. Now, I am actually going to cut these. I'm going to cut a little piece. I'm probably cut this in half, actually. I'm probably going to cut both these in half because I don't have 3 pieces. Now, you can print these covers. These are just included with the kit. I don't feel like printing any, so I'm just going to take these, and you can just snip them. So we're going to put the wire up in the extrusion here. I'm going to put my cord cover over it. And then I'm going to run this down into this extrusion. So I'm going to put another cover up here. And like I said, I'm going to snip this one in half just so I have equal coverage all the way down. Put one right in the center here. Yoop. And I'm not going to put this one in, so this one will go down here. Now I'm going to unscrew. Oh, you can't see it. So I thought I was going to be able to feed this cable in, just drop it through, but there is metal in the way here. But I think if I unscrew this screw, I should be able to just feed this underneath. Let's find out if my hypothesis is correct. This is really awkward having this camera in the way. Okay, am I going to be able to lift this up a little bit? I'm assuming this is just like kind of a sheet metal. Not as flexible as I thought it was going to be. All right, I might have to take out a couple more screws. Probably this one in the corner here. Let me try to orient this so it's not in my face, because it's like making it a million times worse. All right. I think that'll work. Oh, that plate moved up, so that's good. Yeah, I am very happy with these rail covers. Griffin selected those when he was putting these kits together, and I'm very happy with them. Looks like I might have to take this one out too. I'm just trying to slip this underneath here. So this cover needs to just come up a little bit, and this is extrusion under here, so there should be enough wiggle room in there to fit a wire underneath it without getting impaled. See if I lift that up, is it? I'm just peeking under here. Yeah, there is extrusion there. All right, let's go to the bottom side of the printer and see if I can figure out where I'm going to snake this cord through, because on the left side it's blocked as well. I guess worst case scenario, I could come over and slip it in through the LCD. If you put the strip in the back of the printer, you might be able to. Not really. I mean, you could put it in the back, but the uprights are going to block it. But we're going to figure this out. I am determined. I should unplug that from my Pi. Okay. Man, there is a little bit of play in that panel there. Why is this panel not moving up, though? You would think there'd be some give in the panel there. Let me snake a wire through. Like, this is the corner here. Can't remember how these clips is it. Okay. Just looking at how this is attached to here. There's one bolt here. I had a big 4mm Allen key. Where is it? I just gotta make sure when I put it through that I don't pinch anything. That's the concern. All right, so I moved that bolt out. Can I snake this through? Might be able to. Probably should have snaked the end through that doesn't have the regulator on it. But we're going to try. It is small. So, might be able to get away with it. Where's my... I'm going to put the hex in here. Ah, there we go. Put the hex in. There's the regulator. And the end. Now the thing is going to be getting the cable. There is a little bit of like gap between the extrusion and the panel here, as you can see. All right, so I'm going to go ahead and pull this out. Are we clipping the wires at all? Tiny bit. Tiny bit. Just make sure I didn't damage anything. No, they're good. All right. Yeah, there's really no other way in this corner to get the wires in. I'm just looking around here. Bear with me just a moment. I was expecting there to be a hole there. Womp womp. Let me see. No, I should be okay. It's not pinching. These are pretty thick wires. Let's see. Am I able to pull on them? No, I'm able to move them. It's just such a small gap. Now, I wonder if I loosen up these bolts on the left, is the frame going to shift at all? Give me a little more play. No, it's not. There's really no other good way. I'm just looking at the corner here to see if there's any other good way to route these. So, let's see. Can I pull the wire through? I mean, I can pull the wire through a little bit. There is some resistance there. My only concern would be it wearing through the wires over time. Oh, I really wanted to put it through on this side of the extrusion here. I like having clean, hidden installs on stuff. Yeah, so it's like pressing up against the extrusion on the right here. So this cutout here is actually really tight tolerance. It's like pressing between. You see there's tiny little marks there. Where else could I snake this through? Any ideas? Drill a hole? I mean, I could just file it. I mean, there's other ways you can route the wire. I just wanted to do it this way because I thought it'd be the cleanest. Let me see if there's any other like gaps. Usually with these printers, there's gaps everywhere, but apparently Creality tightened everything up pretty good on this printer. Which is surprising. What would you guys do? Looking for your input here. Man, this is... I thought I was going to have a quick and easy install. But no. I could just drill a hole. Maybe I'll do that. What do you guys think? Just say screw it and drill a hole? I don't care if there's a hole in the plate. I'm just looking for another... Because in the back corner of the printer, there's gaps. But I want to mount the strip in the front. I do have a drill. I could just drill a hole. What does chat think? What warranty? This is a Creality printer. Do you think you have a warranty? I also got some oceanfront property in Arizona to sell you. Let's pull this out of here. We're so close. Of course, it has to be something stupid holding up the whole freaking video. I don't really see anywhere else I can, like, snake it through at. Man, if that gap was literally like a millimeter larger, this gap right here in the corner, right here, do you guys see the gap? Like that, if this was a millimeter larger, I'd be good. I'd be golden if it was literally a millimeter larger. All right. Yeah, I think I'm just going to drill it. You guys can do whatever you want on your printer. I don't mind drilling a hole to pass the cable through. All right, so I got to find something that's... I got to drill a hole that's the width of the JST. So let me go in the garage. I'll be right back. All right, I do have a drill bit. I'm going to use, what is this? Well, someone's going to ask, what size did you use? Of course, the stamp is like partially cut out. I think it's 21/64. I can't. It's like literally cut off. See, it's cut off at the top. Focus. Focus. See, it's like cut off. Womp womp. Alright, I'm going to go grab my drill, which I know is in the basement because I was using it down there for the theater screen. I'll be right back. Alright. Don't know if the mic is picking me up all the way over here, but I'm almost back. Battery charged? Yup. Alright. Let's do it. Who would have thought the hardest part would have been getting the cable in? Yeah, I need like extra sets of hands. Whatever, I'll vacuum it out when I'm done. There we go. All right. And I'm going to take one of our stuff. a tool we actually sell. Come on. Just clean up the edge of the hole. Come on, you can do it. There we go. How's that feeling? All right. It ain't pretty down there, but it'll work. All right, let's see. Huzzah! All right. Moving on. Would I spend like freaking 6 minutes on that? There's some shavings in the top here. All right. Put my cable clips back in. All right, since we're down here anyways, let's go ahead and get the power hooked up and the signal pin hooked up. So my power needs to go down to the power supply, which is right here. Oh, look at that. It's like the perfect length too. All right, so power supply can go down here. I have 2 wires already going here from my EZABL. Now, if we look here, we've got pins that are all taken up. Now, on this board, it's the same as the 422 and the 427. You have a couple I/O pin options. So, let's say you're using the BL Touch. You could use the Z pin here. But since I'm not using the BL Touch, these 2 pins are actually not even used here. So these are the 2 BL Touch. You see the in and the out. Those are these 2 pins. We're going to take this plug out, which of course they freaking hot glued. And I'm going to go in on the out pin here. Just going to plug that on there. And then I just got to hook my power up. Now for power, I actually could come off the fan headers here because those are always on. But I'm just going to go right off. Could go off the fan headers, although I put ferrules on there already. All right. Where's my Phillips? Yeah, I was thinking about putting a grommeter on there. I could like print one even. I might have grommets elsewhere. I reamed it out. There's no sharp edges. But for finishing it off, it wouldn't look too shabby. What I think I'll do is, so this is my EZABL power and my LED. They don't pull much. I think I'll put some ferrules on here. Or should I do it? No, it's gonna be, even if I use the red spade connectors, it's gonna be too small. Don't ever use ferrules in this like type of configuration with the with high amp draw loads, but for something like this that's pulling minuscule amounts, I'm okay doing that. I need to put this bolt back in for the upright before I forget. I'm in the top right corner. Remember I took that bolt out? I'm just putting that back in. Make sure this is all flush. All right. Yeah, I'll probably print one. I have grommets in the garage. I might have one that'll fit that hole. All right, so I'm just going to put a ferrule on these and stick them onto the power supply terminal. You could do like a red fork terminal on this, but I think those are going to be too big still for this small wires. So, all right, those are both in there. So this would be the next best thing. Yeah, I remember I had the wires going under there that were just bare wire anyways, so. All right, so plus to plus. Negative to negative. There we go. All right. So I'm going to go up top. I'll close this bottom panel up later. You guys will need to see me put a bottom panel on. Let me put this corner cap back on. Direction is going like that. No? I'm so confused at how this went on. Wait. This way. There we go. All right. Let's zoom out. So we got our... So remember, we came off the out pin on the 5-pin header. We got our power connected. Let me flip this back up. This corner piece did not go back on all the way. Good enough for government work. Okay. So all I have left to do up top here is situate the cable in the track so it's not flopping about. Where is the, I had 2 more of these. Here's one. I'm missing one. I had 4 pieces. So I'll put one in the center here. Where's the 4th one? Because I got one up here, and there's one here. Where's my 4th piece? I need a bigger desk. Or work table, I should say. Is it underneath? No, it's not underneath. I'm missing one of the covers. I had them all up top here. This does need to get cleaned up. It's starting to get messy. I don't like messy. Where did this other cover go? Alright, well, I'm going to go ahead and put the screws I took out of the top here back in when I was trying to route the cable in. Where did those go? Remote, you were getting in the way. Oh, they're over here. Okay. I want to know where the other cable header went. I don't see it. I'm just going to move this one down. I'll put the center one back in when I find it. Wherever it is, Oh, huh, wait, nope, that's a zip tie. Son of a bitch. No, that's not the 2.5. Where's my 2.5 Allen? I need the ball end to get in the corner there. Here it is. All right. I just got to put this one bigger guy back in. That's frustrating that it was just off enough that I couldn't just slip it through. I looked at it, I was like, oh yeah, I can slide that through. Nope. The printer gods are not on my side today. Apparently. It's okay. Bust out the Milwaukee. We'll go through it. I still don't know where that other cable hider is. Oh, it's all the way over here. Yeah, I'm thinking before tomorrow, I got to get this desk all cleaned up because there's too much crap on here. And I get stressed out when my workspace is a mess. Here's the 3. So I was looking for a 3mm T-handle. Yeah, maybe you guys will get lucky. If you have an Ender 6, maybe you'll have more of a gap on your panel in the frame than I will. But I honestly don't care that there's a hole there. Oh, God. My freaking camera caught my wire. Okay. All right, so here we go. Sans trying to get the wire in. Not that bad of an install. Here we go. So I got the wire hider here. There's one here, and one here. And it goes down into the hole. You can see there. Doesn't look too bad. And I reamed that out with my little, what is that? The deburring tool. So, and I think what I'll do is I'll print like a little thing to go in here to like go around the wires and just keep stuff from falling in. Remo, go lay down. Go. He's trying to get me to take him outside. He was just outside. He does not understand that humans have things to do. Okay, let's do smoke test. Did I mess anything up? It shouldn't do anything. Now, these lights, I do want to point out, anytime you're doing NeoPixels, okay, because that's what these are. These are NeoPixel compatible lights. They're WS2812s. They will not light up even if they have power. They have to be instructed by your firmware to turn on. So if you plug them into power expecting them to light up, they will not light up. That is normal. So luckily I have VS Code loaded, and I think I still have the firmware from yesterday in here. Yes, I do. All right. So let me just exit all my random crap here. Share my screen with you. So I'm going to put the SD card in my reader because I need that to flash. Now, I do not remember what pin number that is, but this is the process. So you have the EZNeo 220. This will go ahead and tell it how many pixels you have and that you have pixels, and then you tell it the pin. So now I'm going to go to our website, and I'm going to go to the help center, so support.th3dstudio.com. Scroll down, EZNeo lighting kits, and I'm going to click, I think this is outdated, so the 42X, this should be labeled, yeah, so I relabeled it. So the 422, 427, 431 all share the same stuff. So I plugged in to the out pin here, which should be PB1. So I come back over to my firmware here, I tell it I'm on PB1, and I'm going to save it and compile it. And that should be it. Hopefully that pin's correct. I believe it is. Let's double check while it's compiling. STM32F1, Corelli 431. Let's see. PB1 should be mentioned in here. Oh, it's not. Oh, wait, because it shares a config. So pins, Creality V4, PB1. Okay, yeah, so it's all the same. It's all the same on here. Why do they have this listed as in and out? What do I have this listed? So PB0 is in. PB1 is out. Are the Marlin notes wrong? Or is my image here wrong? PB0 in. I know I've tested this on the actual board. Are Creality's notes? So I have out listed as PB1. They have in. And they have out listed as PB0 when I have that as in. We'll find out. If the strip doesn't light up, then I'll switch that and I'll have to update the picture. But I know I checked that on an actual board by hooking a strip up to it on the bench. But, all right, firmware's compiled. Let's see if this all works. So now here's the thing. You can see I got 2 compiles here. Here's the one from yesterday. I want to use the latest one. So I want to use the bin file with the newest date, which would be this one here. You can see they get a different name every time they're compiled. So I want to copy this one from 9.14. I'm going to go over to my USB drive, or my SD card, I should say. And let's go ahead and safely pull that out. And we're going to go ahead and put it into the printer. Now, if my notes are correct and I have the right I/O pin, they should go through a startup sequence after the firmware starts. So I'm putting the SD card in. I'm turning it on. Hopefully it'll flash. Looks like it's flashing. It's thinking. Let's see. Oh, look at that. Marlon's documentation is wrong. Mine is right. So the notes in there are wrong. So my documentation is right. So PB1 is actually the out pin. Imagine that. All right. So there we go. They're working. And I'll turn the lights off just so you guys can get an idea. So here, let me turn my fill light off. So my fill light's off right now. I'm going to go to the LCD. I'm going to hit EZNeo. I'm going to turn them off and on. See how bright those are? I'm going to turn the lights off in the room just so you guys can get an idea. They're really freaking bright strips. So there's the light off. Now, obviously some of it's hitting the bed right now, which I knew. But let me move my Z down. So if my Z is like, let's go like 50 down. Oh, yeah. Let's see how it looks with 100. Still lighting up pretty good. I mean, in person, you can see everything is pretty well lit up. Now, this is cool. So I can actually go and change colors right from the LCD menu. So I do EZNeo. So there's presets on some boards. So this is just straight white, which is a little bit darker. Here's red, orange, yellow, green, blue, indigo, and then there's nice violet too. Now, when you go ahead and start a print, it's actually going to go through and do like a little progress bar. So let me slice something up and I'll show you what that looks like. It does this all automatically. Now, you can also control these over G-code commands. So if you do a G-code command, I'd have to look up which one it is, but there's G-code command. You can set each individual pixel a different color with a G-code command. So you could put things in your starting code to change LEDs depending on the status or progress in there. And I know there are plugins for Octoprint to get advanced status with the LEDs if you do have lights like this. Now, the main reason I like these is because I have cameras on these printers, and if the lights are off in the room, I can't see anything. Whereas now, each printer is going to have its own light as I go around and put these on each printer, and I'll be able to see it whether the lights are on or off in the room. And the light will turn green when the print's done. So I'm going to slice something up that's just a small... where's my... I think I have a calibration cube. I used to have one. I don't know if I still have it. My buddy Tyler made it for me. I'm trying to find if I have it here still. I guess not. Maybe Tyler's watching. He can send it to me. All right, let's just do a CaliCat. That's a quick print. Drop the infill down, like 10% infill. All right, I'm going to get this sliced up. Save it to the SD card. And I will check chat in a sec, so just give me a second here. Oh, I got to replug the card reader because I ejected it. I'm going to delete the firmware off the SD card before I pull this out of here. All right. So I'm going to put the card in. I'm going to show you guys what it looks like when I start a print, because Marlin will auto-control these LEDs. And it's pretty cool. All right. So I'm going to go ahead and start a print from the SD card. Do print from SD. I'm going to do CaliCat, and I'm going to hit print. So the bed's heating. So it basically will start with like a blue color, and then it'll cycle through to red. And you can see there, it's able to control each individual pixel. So like looking at the printer, I can tell it's pretty blue, and I know it's in the heat up process. But I'll just let that go. Now it'll be more gradual. You're going to start seeing it getting more kind of purpley colored. But then when the print starts, it's going to go full white, which will be nice. All right. Let's check chat while this is preheating. See what you guys been chatting about while I was drilling holes in my Ender 6. I guess drilling holes is slightly less crazy than, you know, cutting the frame. You guys are not super chatty today. I mean, you're chatting, but not too many questions or anything. Jonathan Bear's asking about connectors that we sell. We don't sell any connectors right now. I want to get what I just used, those little ferrules. I want to get those in the shop. But I have not ordered them yet. Shipping on them is really high because they're heavy. I would have put a light bar forward and back. Now, you could... Now, here's the thing. You could wire up two of these in parallel. Okay? You could wire two of them in parallel. And what I mean is, if you made like a splitter here... So, like, now that I already have this up here, I could make a little splitter to have a second... Or have two plugs here to, like, kind of split it, and then run another cable to the back. And then they would be controlled in parallel. You won't be able to control each one of these individually separately, but like when you tell LED 1 to turn on, when you tell LED 1 to turn on, LED 1 on both strips will turn on. So it starts from here, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 strips. But you could do that. You could run two of these strips off of this little step-down board we have. I've done it. The board, like I said, is rated for 1.5 amps max output. The max draw these strips will ever take is up to 1 amp, but like I said, typical load or typical draw on them is about 0.5 to 0.6. So you'd be well within tolerances. So, And if you're using an EZboard V1 with the EZNeo module, that's up to 2.5 amps output. So, but you can see it's changing the colors. And we've got one. So I've noticed that in Marlin, the first LED stays white and the rest is the progress bar. I don't know why. It's just what I've noticed. So, but you can see there, it's almost at temp now. And you see, it's so hard. It's very subtle to notice, but you can kind of glance over. Like if you're used to how the LEDs behave, you can kind of tell where you're in the heat up process. Oh, it's still pretty blue. Oh, well, you know, oh, it's still waiting for the bed to heat, but now it's getting really dark red. And then eventually it should turn white. It's almost at temp. We're at 228. It's just waiting for it to stabilize. I had to reflash the firmware, so I didn't do PID. There they go. But yeah, so they're pretty cool. So now you can actually see, like, even though the lights are off, I can clearly see the first layer on here when this starts going. Thanks to the lights. But you can also control them. So let's say I don't want them. Where is it? EZNeo. Oh, hang on. My camera's getting in the way. Let me move this. Okay. Oh my god. All right. So anyways, hang on. Let me tell my G home. Let's get the lights back on here since I'm not a hermit. But yeah, pretty happy with this. Basically, as I'm going through all my printers and doing maintenance on them, like this one, like I said, was taken offline because that extruder issue it had. And I'm going to be doing this to my machines where if they don't already have the NeoPixels on here, I'm going to go ahead and add them on. So, but you can also change the colors while it's printing. So like I'm going to the LCD menu right now and you can just change the presets if I want to like different colors. You can also set in G-code whatever different colors you want and have it auto change. So, ooh, I kind of like the blue. Blue. I'm going to go back and just set it to white. Just leave it at white. So anyways, you can actually see the light because this is not my... If I turn this off, the light off the shroud is actually not... That's from the lights. So they're way brighter in person. I don't think the camera really conveys how bright these really are. But... Oh, God. Oh, God. There we go. Yeah, so the cool thing is, and I did this on a video, I actually have these strips underneath some speakers in my home theater because they're NeoPixels. You can use them with ESP8266s, you can use them with Raspberry Pis, you can use them with anything that is compatible with the NeoPixel protocol. They're not a proprietary protocol. Tons of the open source stuff supports it. So, but yeah, she's printing. I had some shmoo on my noozle, apparently. I'm not even going to touch it. I'm going to get my finger caught. So, but yeah, this printer's ready to be put back in service. This is the last upgrade I want to do to it while I had it down. And yeah, we're doing some CaliCat. But I like them. I think there is a benefit to doing the PCB style like this. I think there's a couple. I think there's only one other company was like Adafruit or something. They have some NeoPixels that are on a PCB. But the main thing I like the PCB for with the pixels is heat. A lot of the cheaper strips I've had that are on like those flexi strips, I have really high failure rates with them. I'm curious to see how the ones in the home theater screen setup are going to last because they are mounted on an aluminum extrusion, which should act as a heatsink, hopefully. But I feel like, in general, the ones on the flexi strips, you get maybe a year out of them and they start dying. You know, and they do run hot. So, any kind of heat dissipation would be good. I'm going to crank the fee right up a little bit. I should have done something that was only a couple layers, because, I mean, really all that's going to happen after this is the print's done, is the lights are going to turn green, and as soon as you press the LCD button, they'll go back to white. Do they go back to white or they shut off? I can't remember now that I think about it. I have these on I have Neos on a couple printers. I want to put these on the Daedalus too. I know Joe said he got them working with the Duet board, because the Duet boards apparently support NeoPixels as well. And I believe he said, now don't quote me on this, I'm not a Duet expert, but I believe Joe from Project R3D told me that the Duet 3, which was in the Daedalus, I think he said that it does have a 5-volt regulator, so you would not need a separate regulator on the Duet 3. But they should say, if they got extra, you know, if they got like an amp extra power output, they'll probably be fine. So, like I said, the rating, the 1 amp rating, that's just a conservative rating, because I don't want anybody going, well, you said it only took half an amp, but, you know, it's drawing 0.8. I'd rather say it needs more than it does, because then you have some headroom. But you can see this is printing great. That little pancake. I'm printing with some what is it? The Cobalt Blue? Yeah, Cobalt Blue from Coex. But here, like, let me turn my fill light off. So that's just the light from the EZNeos. Let me do the test here with turning my main lighting off here. So there you go. That's just the EZNeos lighting that up right now. "3D Wildcat says, if they're on a channel that lasts about 2 years or so, PCB will last 2 to 3 years. That's good to know. One would assume that if they're not running as hot, they should last longer. You know, I could have easily got, you know, like just cheap strips cut to a certain length, but, you know, I was like, I'd rather do a PCB. Here, let me see if I do, so you can actually set, I'll show you this right here. You can actually set on the software here, you can actually change through the LED control. So you can turn them, you know, on and off. Okay. Or you can do presets. Okay. Fun fact, the default setting is actually TH3D blue, which looks really white. But you can go ahead and you can see here. So this is the TH3D blue, which is the A2CBE1 hex code converted to RGB. But you can literally go in here and just dial in your intensity, and it changes as your here. So I'm going to dial the green all the way up to full, and then I'm going to dial the blue back, or sorry, I'm going to dial the green all the way up to full, and then I'm going to dial the blue back and show you guys, because it does it in real time. So watch the light color change. So it should get very green in a sec. Hang on, let me get that in focus. All right. Oh, I backed out of the menu. Hang on, custom lights. All right, blue intensity. I'm turning the blue all the way off. I'm scrolling it. So yeah, that's just green. That looks kind of cool. That looks kind of cool, I'm not even gonna lie. I'm turning the blue channel back up. That's at full intensity, which is 255. I'm turning the red channel up. So we should get, so all three should be full blast, which would basically give us white. There we go. It's kind of like a cool white. But yeah, we'll let that finish. This printer's printing really nice. I don't know if you guys can see that very well, but yeah, it's printing pretty good. But yeah, that's just the EZNeo's lighting this up. So I'm gonna turn my fill light back on. So a little bit, but yeah, they're damn bright. I like them. All right, now the room lights. Yay! One more printer fixed, and you guys got a couple videos out of that. How's that? It's printing so great. I'm so happy. We'll see how much more printing I can get out of this before something else breaks on it. Hopefully nothing else breaks on it. I do want to point out that Creality's, or not Creality, but Marlin's notes on what pin is in and what pin's out, according to the silkscreen, is actually wrong. I was second guessing myself there. I was like, no, that can't be correct, because I tested all 4 pins that are listed on that document for these boards. So, yeah, this was not a very heavily modified printer, and now I can no longer say that. It's pretty heavily modified now at this point. Ooh, here's a let's thing, because I don't really care if this finishes. I wonder what happens. What do the LEDs when I hit stop print? So I'm gonna hit stop print. Let me go back to autofocus, because otherwise I'll forget that it's on manual. Let's see what happens when I tell it stop print. Like, what does it do? Stop. Do the lights just stay on? Yeah, they just stay on. All right. But yeah, I'll show you. So if I power cycle it, so I turn the printer off, okay, and turn it back on, you'll see they go back on. Did you guys see the power cycle, or the cycle start? Hang on. Watch, they'll cycle through RG and B as a test. And then they go white. Yeah, that's printing pretty good. I'm happy with that. How nice that looks. Not bad. Infill gives a little give there, but not too shabby. I'm going to have to play with the speeds on this, see if I can get this going a little bit faster. But the bridging looks good. No overheating on the tail. All right. Well, this printer doesn't have a catchy name, but she's all done. Now she's got some TLC. We got a 5015, we got bed leveling, we got easy flex. Got all sorts of fun stuff. How are my belts? Belts feel good. And we also got lighting now. I just got to put the bottom back on. All right, well, this wasn't going to be a super long stream. What is this, like an hour, hour and a half, if that? But yeah, I hope you guys enjoyed this. I hope you guys get some lights for your printer. Make sure to use the discount code. Is this still on my clipboard? It is not, because I made a code. I'm only going to post it here as a thank you for watching. So if you want to get your own EZNeo strips, use the code EZNeo 20% off, and that will be valid for the first. I think I have it set for 25. I might up it to 50. But the first people that use the code will get that discount. I'm going to do it 50. So first 50 people who use that code will get 20% off the EZNeo kits. The EZNeo kits are $24.99. The universal power adapter that we use to power these on this printer is only $5. If you have an Easy Board V1, we do have a plug-on adapter, so there's no soldering at all. You plug it on, turn on the firmware, and you're good to go. That's also $5 as well. You can add on the universal power adapter or Well, you would only need one or the other. You can add on the power adapters on the actual EZNeo strip page itself, and they are discounted on that page. So if you guys do need a power adapter, make sure you get it with the strip so you can save a couple bucks. Anyways, I'm just going to go here and modify that code because I think I left it for only the first 25 people, and I'm going to make it the first 50 people that use it. Let's see, usage restrictions, usage limit per coupon, and we're going to set that to 50. All right. So anyways, hope you guys learned something. I'm excited to get this on here. I think it's going to give me a little more motivation to get them on the rest of the printers. I don't have too many machines that need maintenance right now, so, but it does look pretty cool. I like lighting, if you guys couldn't tell. Hence, here, would you have any idea that I like lighting at all? No, what could give it away? Anyways, I'll stop yammering on. Hope you guys learned something. Hope you guys enjoyed the stream. And as always, happy printing. I will see you guys tomorrow at 5 p.m. on the Ask Tim. Take it easy. I'll see you guys later.